Welcome back to the Data Analyst. Today we are diving into a key concept in time series analysis, the Backshift operator and how it used in ARIMA models. What is ARIMA? ARIMA stands for Auto-Regressive Integrated Moving Average. AR or auto-regressive means the current value of the series depends on its past values. IO integrated refers to differencing the data to make it stationary. MA or moving average means the current value depends on past error terms. Together, ARIMA is written as ARIMA PDQ. P is the number of AR terms, D is the number of differencing steps, Q is the number of MA terms. So in this session, we are focused on how to write backshift operator to different types of ARIMA models. In here, ARP, we can write it ARIMA P00 because we don't have D or Q value. That means we don't have integrative part or moving average part. So we can write it as ARIMA P00. This is a general formula to write ARP. So yt equals c plus phi 1 times yt minus 1 plus phi 2 times yt minus 2 plus 5p times yt minus p plus epsilon t. Let's look at the example. So in here we write AR2. Also we can write it as ARIMA 200 because we don't have D and Q value. So we can write it as yt equals c plus pi 1 times yt minus 1 plus 2 times yt minus 2 plus epsilon t. Now we are going to write same thing with backshift operator. So if you don't know what is backshift operator and basic of backshift operator, please go and watch this video. But for now, I will remind few things. Byt means yt minus 1 and b squared yt equal to yt minus 2. So with the backshift operator, we can write it same formula using b like this. Yt equals c plus phi 1 times b times yt plus phi 2 times b squared times yt plus epsilon t. Then yt minus phi 1 times b times yt minus phi 2 times b squared times yt equals c plus epsilon t. And again we can write it as this way. 1 minus phi 1b minus phi 2 times b squared altogether yt equals c plus epsilon t. Next example, AR3. Also we can write ARIMA 300. So this is the basic formula. Yt equals c plus phi 1 times yt minus 1 plus phi 2 times yt minus 2 plus phi 3 times yt minus 3 plus epsilon t. So with the backshift operator, we can write it as yt equals c plus phi 1 times b times yt plus phi 2 times b squared times yt plus phi 3 times b cube times yt plus epsilon t. So in here what we did was just substitute the backshift value into this formula because we already know yt minus 1 equal to b times yt and yt minus 2 equal to b squared yt, and we already know yt minus 3 equal b cube times yt. So what we did was just the substitute value into the basic formula. So finally we got open bracket 1 minus phi 1 times b minus phi 2 times b squared plus phi 3 times b cube close bracket and yt equals c plus epsilon t. So in here we have MAQ. So in here we don't have autoregressive and integrative part. So MAQ we can write it as ARIMA 00Q because we don't have P and D value. So this is the general formula for MAQ. Yt equals C minus theta 1 time epsilon t minus 1 minus theta 2 times epsilon t minus 2 minus theta 3 times epsilon t minus 3 minus theta q times epsilon t minus q plus epsilon t. Let's look at the example. So in here we have MA3. That means ARIMA 003 because we don't have P and D value. So this is the basic formula. Yt equals C minus theta 1 times epsilon t minus 1 minus theta 2 times epsilon t minus 2 minus theta 3 times epsilon t minus 3 plus epsilon t. Before writing same formula with backshift operator, there are a few things that I want to remind. That means epsilon t minus 1 equal to beta epsilon t and epsilon t minus 2 equal to beta squared epsilon t and epsilon t minus 3 equal to beta cube epsilon t. Like previously we learned how to write yt minus 1 value with the backshift operator. So likewise it's the same thing. So let's write the same formula with backshift operator. Yt equals C minus theta 1 time B times epsilon t minus theta 2 times B squared times epsilon t minus theta 3 times B cube times epsilon t plus epsilon t. Also we can write it as this way. Yt equal C minus open bracket theta 1 b plus theta 2 b squared plus theta 3 b cube minus 1 close bracket and epsilon t. So in here we don't have a integrative part, AR and MA part only. So we can write it as ARIMA P0Q because we don't have D value. So this is the general formula. Yt equals C plus phi 1 times yt minus 1 plus phi 2 times yt minus 2 plus 5p times yt minus p minus theta 1 times epsilon t minus 1 minus theta 2 times epsilon t minus 2 minus theta 3 times epsilon t minus 3 minus theta q times epsilon t minus q plus epsilon t. Let's look at the example. In here we don't have integrative part, so ARIMA 202. This is the general formula without backshift operator. Yt equals C plus 5 times yt minus 1 plus 5 2 times yt minus 2 minus theta 1 times epsilon t minus 1 minus theta 2 times epsilon t minus 2 plus epsilon t. And again we can write it as this way. Yt minus phi 1 yt minus 1 minus phi 2 times yt minus 2 equals C plus epsilon t minus theta 1 times epsilon t minus 1 minus theta 2 times epsilon t minus 2. Again with substituting the backshift operator values, we can write it as yt minus phi 1 b yt minus 5 2 times beta squared times yt equals C plus epsilon t minus theta 1 times b times epsilon t minus theta 2 times b squared times epsilon t. And again we can write it as open bracket 1 minus phi 1 b minus phi 2 b squared close brackets yt equals C plus open bracket y minus theta 1 times b minus theta 2 times b squared close brackets and epsilon t. Now we are going to write ARIMA model with integrative part. Look at this example. So in here we have ARIMA 2, 1, 2. In here we have auto-regressive part, integrative part, and the moving average part. So now you know how to write ARIMA 2021, because in the previous example we learned how to write ARIMA 202. So in here what you have to do is just put the integrative part. So we already know AR2 is 1 minus phi 1 b minus phi 2 times beta squared times yt. So in here we put 1 minus b, that is integrative part. Integrative 1 mean 1 minus b, and equal c plus, then write the moving average part, open bracket 1 minus theta 1 times b minus theta 2 times b squared times epsilon t. So in here we just only put 1 minus b into the left side of the formula. That's it. Look at the next example, ARIMA 222. In here we have integrative part as a 2. So then what you have to do is just put 1 minus beta squared into the formula, into the left side of formula. So if you have integrative part as 3, then what you have to do is put the 1 minus b cube into the formula, into the left side to the formula. That's it. These are the practice questions. So write these with Backshift Operator. There are 10 ARIMA models, and what you have to do is write the formula with Backshift Operator. Now, I am offering you a very rare opportunity. Take on the practical questions, subscribe to my channel, and then send your completed answers as a PDF to this email address. This opportunity is limited to the first 10 participants only. I will personally review, mark your answer sheet, and send it back to you. In addition, I will feature your name in the comment section as a recognition. Don't miss out, only the first 10 participants will be selected. I hope this video made the concept a lot clearer for you. If it did, make sure to hit the like button, subscribe, and share this with your friends who are also learning time series analysis. Thanks for watching, and see you in the next one.